Hi, this is Mr. Manley. In this video, I'm going to look at function operations. Here I've got two functions labeled R and S. Now remember these letters here. This R is not a variable, it's a name. It is naming the function R. And then also remember that this letter with this x, it's not multiplication. It's not r times x. It is r of x. Now r is the name of a function that cubes things. That's what this x cubed is about. It's saying that's what happens to a number when you put it in the function r. So in this video here, we're starting off with function operations. Just like we operate upon numbers or we operate upon variables, addition, subtraction, multiplication, division, we can operate on functions. And what does that mean, operating on functions? It means operating on a pair of algebraic expressions. So I've got two algebraic expressions here. I have the x cubed one, which is the operation or what the function r does to numbers, and I have the s expression, 4x squared is what s does. So quite simply, if I want to do r plus s of x, I just add those two expressions. So r is x cubed, and then s is 4x squared. Subtracting, r is x cubed minus 4x squared. Now this r times, now this, we see there's a difference here, right? I've got the operation of r and s, and it's multiplication. So I had addition, subtraction, now multiplication. And then I also see this, I had an x here. An x here. Now remember, I'm not multiplying that by that x. This is not r plus s times x. It's r plus s of x, which is saying I have some new function, which is the combination of r and s. And here it's the addition of r and s. Now this is saying I have some new function r and s, which is some combination of r and s, and I want to substitute a -1 into that function. Now I'm not multiplying that function by -1, I'm substituting a -1 into that function. So there are two ways to think about this, and I'm going to take a look at the first way, which is if I look at r times s of x, instead of jumping into the -1. So I'm going to look at combining the two functions. And what would that mean? That would mean that I'm doing r, the function r is x cubed, times s, which is 4x squared. And then I can simplify that to 4x to the 5th. So this is r times s of x is 4x to the 5th. And then if I want to know what's r times s of -1, then I'm going to plug the -1 in. I'm going to plug this -1 in here. Does that make sense? How if I just go back here a little bit and say it like this, that r times s of x is 4x to the 5th. And then if I want to know what's r times s of -1, you see the -1 is getting substituted for x. So I'm going to substitute the -1 in here. So that gives me 4 times -1 to the 5th. -1 to the 5th is -1, so that's -4. All right, so that's one way of approaching this. And you can look at that and copy that down. And then I'm going to look at another way of approaching it. The other way of approaching it is to do r of -1. So I'm plugging a -1 into this function r. So what's that going to be? That's going to be -1 cubed, right? -1 cubed is -1. And then I do separately s of -1. And that's plugging in a -1 into the function s, which will be 4 times -1 squared. -1 squared is +1 times 4 is 4. And then, so now I know what r of -1 is. I know what s of -1 is. So I say that r times s of -1 is equal to -1 times 4. So do you see what I did there? I figured out r and s separately, and then I combine them. And of course I get the same result. So you can use either of those methods. The answer here is -4. And that's something to notice, that whenever I have a value, a numeric value in here, I'm always going to end up with a numeric value over here. If you're ending up with a variable over here, if there's an x that shows up in your solution when there's a number in the parentheses here, you've misinterpreted something. Okay? So that's combination, an introduction to combination of functions. Okay, here I'm going to look at another combination and also get into domain here. Now I have a separate video on domain, and if you have questions about domain, you should have watched that video or go review domain somewhere else. So here I've got f plus g of x. Look at this. All I'm doing is this. That's f plus that's g. And that's it. That's all I can do with this combination, or with this operation on functions. F plus g of x. F is 2x minus 1. G is 3x plus 5. And there's no way to combine those. Now for the domain of this, I'm looking at this expression, and the limitation on the domain, which is the possible inputs, what values of x can I substitute into this function? The problem is the radicand. So I need this radicand to be positive or 0. So what I'm thinking about is, when is 3x plus 5 greater than or equal to 0? So then it won't be negative, but it could be 0, so I can have it equal to 0. And then just solving, I solve for x in this inequality, and that's it. X is greater than or equal to -5/3. And then we've got this interval notation that you've been seeing. Hopefully you've seen this by now. And we want to write, this is called set builder notation. And that's what you learned in algebra and algebra 2. But now in precalculus, we're going to a more advanced form of notation called interval notation, which is that's these here, interval notation. And the way I write x is greater than or equal to -5/3 in interval notation is bracket -5/3. So the bracket means that it can equal -5/3, and that's in the inequality here, right? The equals there means it can equal -5/3, so that gets a bracket, and then up to infinity. And then this other one here, f times g, again, there's really not anything to do with this. I've got f, you got to have these parentheses around f, times g, don't need any parentheses around that because the radical acts as parentheses, And that's it. That's all we can do with that. F times G. And then I have the same interval here for the domain. Okay, let's look at one more here. Now here's one. Remember that one that we looked at where we had f times g of negative 1, or it was r times s of negative 1, I think. So we had r times s of negative 1, and there were two different ways that we could have done it, right? So I'm gonna choose a way to do it here. And remember, there are two different ways to do this f over g of 5. So this f over g of 5, if you look back at the r times s of negative 1, there are two different ways of doing it. I'm going to choose my way here. And the way that I'm going to do it is I'm going to do f of 5 and f of g. So I'm going to do f of 5, which is 5 minus 7 is negative 2. And then I'm going to do g of 5, which is 1. So I'm putting a 5 in here. 5 minus 4 is 1. So that's getting me 1. And then I'm putting a 5 in here. 5 minus 6 is negative 1. So I've got 1 times negative 1 is negative 1. And then I'm going to do f divided by g. F of 5 divided by g of 5. And I can just go down here and put that in, right? So I'm going to have negative 2, that's f of 5, over negative 1 is g of 5. And that equals 2. All right, and then we have the other way that you could have done that, and you're free to do that as well. Now this says values that are not in the domain of g. So if I think about f of g of x, right? If I think about that, then instead of f over g of 5, what would I have? I would have the f over the g. And what's the domain problem here? The denominator cannot equal 0. So what values are not in the domain? The values that would make the denominator 0. So in this case, I can't have a 4 and I can't have a 6. Now that's different than asking what is the domain. This is asking what is not the domain, not in the domain. So just be aware of that distinction when you're working on a problem like this.